Hi everyone. In this video, we're going to be doing 9709 paper 13, Pure Maths 1, May, June 2025. This paper is 1 hour 50 minutes long. So without further ado, we'll try to finish this within the time limit. So without further ado, let's get started. Okay, so for the first question, we're told that a curve has this equation, and we're supposed to find the equation of the tangent to the curve at this point. And we're supposed to give our answer in the form y equals mx plus c. Okay, first of all, to find the equation of the tangent at a particular point, you have to know the gradient at the particular point. And to know the gradient, you're going to have to find dy dx. So let's do that. So first, let's write the equation as y equals 2x plus 12 times x to the power of negative 2. Now, to find dy dx, just differentiate with respect to x on both sides. You get first differentiating 2x, you would get 2, and then differentiating 12x, you keep the scalar outside the constant term, and you differentiate x to the power of negative 2 separately. So you bring down the negative 2 and you subtract 1 from the existing power, so this would be x to the power of negative 3. So final answer for dy dx is 2 minus 24 x to the power of 1/3, to the power of negative third, negative 3, sorry. Okay, and now we're going to have to substitute the points into dy dx to find the equation, to find the gradient. So we're going to sub x equals to negative 2. So hence, this would give us dy dx equals to 2 minus 24 times negative 2 to the power of negative 3. So this, just type into your calculator, you would get 5. So hence, m is equals to 5, and we can write y equals to 5x plus c. And now to find the value of c, we're going to substitute the set of coordinates. So we'll substitute x equals to negative 2 and y equals to negative 1. So this would give us 5 times negative 2 plus c equals to negative 1. So this would be minus 10 plus c equals to minus 1. And this will give us c equals to 10 minus 1, which is 9. So hence our final answer would be y equals to 5x plus 9. So this is our final answer for this question. Let's head on to the next question. Progress. Okay, so for this question, we're given the first two terms of a geometric progression, 4 sine squared theta and 8 sine cubed theta, where theta is an angle such that theta is between 0 and pi over 6. We're also told that given the sum to infinity of the progression is half, we have to find the value of theta. Give your answer in the form sine inverse k, where k is a rational number. Okay, so first of all, a geometric progression is like 1, 2, 4, 8, 16, and so on. And as you can see, to get the next term, we have to multiply by 2. And in this case, 2 is the common ratio. So this is a general idea of what a geometric progression is. So in this case, let our first term be A. Okay. And let's take a look at our formula list for geometric series. So this is the formula for the general term of a geometric series. So n is for the nth term. So A is the first term and R is the common ratio. So let's write down that formula. Un equals to A R to the power of n minus 1. So U2 is equals to 4 sine square theta times R to the power of n minus 1. N minus 1, that's 2 minus 1, so it's just R. So hence 4 sine square theta R is equals to 8 sine cube theta. So R is just 2 sine theta. Okay, so this is our value of R, the common ratio, 2 sine theta. And now let's look at the formula for the sum to infinity. So this is the formula for the sum to infinity, A over 1 minus R, where the modulus of R is less than 1. So let's write down S inverse equals to A over 1 minus R. Okay, so 4 sine square theta over 1 minus 2 sine theta equals to 1 over 2. So cross multiplying, we'll get 8 sine square theta equals to 1 minus 2 sine theta. Now moving everything to the left-hand side. So we are going to have to add 2 sine theta to both sides. So plus 2 sine theta and subtract 1 from both sides. So minus 1 equals to 0. And now we are ready to solve the equation. So if you can see, this is actually a hidden quadratic in terms of sine theta. So we can just use either the quadratic formula or factorization to solve for sine theta. So let's do that. Okay, so for me, I'm going to factorize. You can also use the quadratic formula. So this is 4 sine theta minus 1 times 2 sine theta plus 1 equals to 0. Okay. So let's equate each factor to 0. So 4 sine theta minus 1 equals to 0. You would get sine theta equals to 1 over 4. And then for the second one, you'll get 2 sine theta plus 1 equals to 0, and sine theta would be minus 1 over 2. Okay, so in order to know which value to reject, let's take a look at our given domain for theta. So theta is between 0 and pi over 6. And in our unit circle, that lies all within the first quadrant only. And in the first quadrant, uh, we have the letter A, so that means sine must be positive. So hence, we're going to have to reject the negative value. So hence, theta would just be sine inverse 1 over 4. And this would be our final answer for this question. Let's head on to the next question. Okay, so for this question, we're told that given that this integral is equal to 12, we're going to have to find the value of the constant A. Okay, so first of all, let's evaluate this integral, this definite integral. Plus 2 dx. Okay, so to evaluate this integral, to make it easier for us, let's re-express 1a over 4x minus 3 squared as a times 4x minus 3 to the power of negative 2 plus 2 dx. Okay, so to integrate this, we're going to have to integrate each term separately. So first we have to integrate a times 4x minus 3 to the power of negative 2. So to do that, we're going to leave a alone because it's not a term in x. So we'll leave that, and we'll integrate 4x minus 3 to the power of negative 2. Okay, so to do that, we're going to have to first add 1 to the existing power. So this would be 4x minus 3 to the power of negative 2. And then we have to divide by the new power. And divide it again by the derivative inside the inner function. So in this case, 4x minus 3, when you differentiate, you'll get 4. So we divide by 4. Excuse me. Okay. All right. So that's settled. Now let's differentiate 2. So, I mean, integrate 2. So integrating 2, you'll just get 2x. Okay. All right. And now let's just put our upper and lower limits. Okay. And now let's plug in our upper and lower limits. So let's plug in 3. So when plugging in x equals to 3, we will get a times 4 times 3, that's 12, minus 3, that's 9 to the power of negative 1, over 1 minus 1 times 4, that's minus 4, plus 2 times 3, that's 6, and then um, minus bracket a times 4 times 1 minus 3. That's 1 to the power of negative 1 over negative 1 times 4, that's negative 4. Plus 2 times 1, which is 2. So let's simplify all this. So we would get um, minus a over 36 plus 6 minus minus a over 4. So this would just be plus a over 4 minus 2. So simplifying this, we'll get a over 4 minus a over 36 plus 4. That's equals to 1 over 4 minus 1 over 4 minus 1 over 36. That's 2 over 9a plus 4. So now let's equate this to the right-hand side, which is 12. So 2 over 9a plus 4 equals to 12. And 2 over 9a is equals to 8. And hence a would just be 8 divided by 2 over 9, which would give you 36. So this is our final answer for this question. Let's head on to the next question. Okay, so in this question, we're told to find the first three terms in the expansion of this binomial expansion in ascending powers of x. So we're supposed to start with the constant term followed by the term with the highest degree. Okay, so to do this, let's first write our unexpanded form. Okay, so in order to do this, we're going to have to look at our formula list. So the formula we have to use is the first one, where n is a positive integer. Yeah, so we're only told to find the first three terms. Okay, so we'll need from a to the power of n all the way to here. So a to the power of n plus n choose 1 times a to the power of n minus 1 times b plus n choose 2 times a to the power of n minus 2 times b squared. Okay, so in this case, a is equals to 2 and our b is equals to negative 3 over 2x. Okay, so first term would just be a to the power of n. Oh, and our n is 5. So hence this would just be 2 to the power of 5. Plus, next term would be n choose 1, so 5 choose 1 times a to the power of n minus 1. So that's just 2 to the power of 4 times b, which is negative 3 over 2x. And then plus n choose 2, which is 5 choose 2, times a to the power of n minus 2, which is 2 to the power of 3, times b squared, which is minus 3 over 2x squared. Okay, now we are going to simplify all these. So 2 to the power of 5 is 32, plus 5 choose 1 times 2 to the power of 4, which is 80, times negative 3 over 2x, plus 5 choose 2 times 2 cubed, that's 80, and then times minus 3 over 2x squared, that's 9 over 4x squared. Okay, so final answer would be 32. 80 times minus 3 over 2 minus 120x plus 9 over 4 times 80 180x squared. So this is our final answer for the first part. Let's head on to the next part. Okay, so for this part, we're gonna have to use our answer to part A with a suitable value of x to find an approximation to 1.985 to the power of 5. Okay, so first of all, let's see the similarities between 1.985 to the power of 5 and our original expression in here. So both our original expression and this, they are raised to the 5th power. So hence, we can equate 1.985 to 2 minus 3 over 2x equals to 1.985. Okay, and we can just solve for x. So make 3 over 2x the subject. So that is just 2 minus 1.985, which is 3 over 200. And then x would just be equals to 3 over 200 divided by 3 over 2. So this would give you 0.01. So this is the value of x that we're going to substitute in our expansion that we obtained in part A. So 32 plus, oh wait, sorry, minus 120 times 0.01 plus 180, 0.01 squared. So just type this into your calculator. You would get 30.818. But since this is exact, it's best to leave it as this answer. And you can also leave it to 3SF as well, which would be 30.8. So these are our final answers for this question. Let's head on to the next question. Look. Okay, so for this question, we're told to solve this equation for the domain of theta between minus 180 degrees and 180 degrees. Okay, first of all, let's write down the equation and try to simplify it in terms of just one term. So either in terms of cosine only or sine only or tangent only. Okay, so first thing we can do is to use a sine theta over cosine theta equals to tangent. So let's use that. So tangent theta would just be sine theta over cosine theta equals to 1 plus 5 cosine theta. Okay, so simplifying the left-hand side, we'll get 4 sine square theta over cosine theta equals to 1 plus 5 cosine theta. So to simplify this, let's just multiply both sides of the equation by the denominator cosine theta. So this would be 4 sine square theta equals to cosine theta plus 5 cosine square theta. Okay, so in order to, and now we're going to have to express sine square theta in terms of cosine theta, since we have just cosine theta only. And if we express cosine theta in terms of sine square theta, this equation wouldn't work out. So we're going to use cosine square theta plus sine square theta equals to 1. So this would just be 1 minus cosine square theta equals to 5 cos square plus cosine theta. Okay, so let's simplify everything. So this would be 4 minus 4 cosine square theta equals to 5 cosine square theta plus cosine theta. Okay, now let's move everything towards the right hand side. So add cosine 4 cosine squared theta to both sides, you'll get 9 cosine squared theta plus cosine theta. And now subtract 4 from both sides, you'll get minus 4 equals to 0. So as you can see, we obtained a quadratic expression in terms of cosine theta. So using the quadratic formula or factorization, we can solve for cosine theta first. So let's do that. I'll try to see whether I can factorize it. Nope, I can't. Okay, so let's use the quadratic formula. So cosine theta equals to minus b. B is 1, so minus b is negative 1, plus minus b squared, that's 1, minus 4 times a, which is 9, times c, which is negative 4, over 2a, which is 9. Okay, so using this type into calculator, you will get cosine theta equals to square root 145 minus 1 over 18, which is a positive value. And then the second answer would be the reciprocal, minus 1 square root 145 minus 1, minus square root 145 minus 1 over 18. This is a negative value. Okay, so now let's see whether we have to reject either of the two values. Okay, so let's draw our unit circle. Okay, and see which quadrant it covers. So 180 degrees, it would be from here all the way to here. So it covers the first two quadrants, and negative 180 degrees is from here all the way to there. So it goes through the third and fourth quadrant. So our given domain for theta goes through all four quadrants. So we can accept both values of cosine theta, both positive and negative, because the first quadrant, A, is positive for both for cosine. For S, it's negative because S stands for sine. Same for T, which stands for tangent. And it's positive for the fourth quadrant, which is C. Okay, so we don't have to reject any value. Okay, now let's solve the equation cosine theta equals to square root 145 minus 1 over 18. So for this, theta would either be in the first quadrant or the fourth quadrant. So either theta can be a positive acute angle, or a negative acute angle. So let's find the positive acute angle first. So just take the inverse of cosine. Just take cosine inverse square root 145 minus 1 over 18. And that would give you cosine inverse square root 145 minus 1 over 8. So this would give you 52.2 degrees to 1 decimal place. Okay, and now to get your negative acute angle, just put the negative sign to your positive acute angle to 1 decimal place. So these are our first two answers. Let's now solve the second equation. Cosine theta equals to minus 145 minus 1 over 18. So since for this cosine theta is negative, theta would lie in the second and third quadrants. So for the second quadrant, theta would be a positive obtuse angle. And then for the third quadrant, theta would be a negative obtuse angle. Okay, so to find out, let's to find theta, minus 180 minus cosine inverse the absolute value of cosine theta. So in our case, that's 1 plus square root 145. Just factor out -1, and you would get 136.4 degrees to 1 decimal place. And then for your second value, it would be the same magnitude, but with a minus sign, since it's also an obtuse angle. So this would just be minus 136.4 degrees to 1 decimal place. So these two are our final two answers, and these are our final four solutions for this equation. And if you want to check whether these solutions are correct, just type the exact solutions back into the above equation on both sides and see whether both sides are equal to each other. So with that, let's head on to the next question. Okay, so for this question, we're told an arithmetic progression has first term A and common difference 2. The big nth term is 55, and the sum of the first three n terms is 5,760. And using all this, you have to find the values of n and a. Okay, so firstly, an arithmetic progression is like 1, 3, 5, 7, 9, and so on and so forth. So to get the next term, you add by a certain number. So in this case, we're adding by 2 to get the next term. So in this case, we can say 2 is the common difference, and the first term A is 1. So this is a general idea of what an arithmetic progression is. Okay, so first let's okay. All right, first let's look at the formulas relating to arithmetic series. So this is the formula for the nth term in an arithmetic series. So A is the first term, and plus n minus 1, which is multiplied by d, which is the common difference. So let's write this down. Un plus A plus n minus 1 times d. Okay, so in here, we are given the big nth term, which is 55, plus A times big N minus 1 times d, which is 2. So let's simplify all this. 2n minus 2 plus A equals to 55. Okay, let's make A the subject in this equation. So this would be 2n plus A. Add 2 on both sides, we'll get 55 plus 2, which is 57. And this would give us A is equals to 57 minus 2n. So this is our first equation. Now let's obtain the second equation using the second piece of information, that the sum of the first three n terms is 5760. Okay, so to use that, let's look at our second formula for the first sum of the first n terms, Sn. So you can see that we're given two formulas here. So this formula requires us to know what L is, where L is the last term in our summation. But since we don't know what L is, we're going to use this formula instead. Half n times 2a plus n minus 1 d. So let's write that down. So Sn equals to half n times 2a plus n minus 1 d. Okay, so let's sub n equals to 3 big N. So this would just be 5760 times half times 3 big N times 2a plus 3n minus 1 d, which is 2. Okay, and let's simplify this expression. So 3 over 2n times 2a plus 2 times 3n, that's 6n, and then 2 times minus 1, that's minus 2. This equals to 5760. Okay, let's simplify this further. Let's factor out 2 from this equation. So we'll have 3 over 2n times 2 times a plus 3n minus 1 equals to 5760. So the 2's cancel out, so now we just have 3n times a plus 3n minus 1 equals to 5760. So this is our second equation, and we have now two equations to solve simultaneously. So since we have one equation in terms of A, we can just substitute the first equation in terms of A into the second equation. Oh, so this will be 3 big N times 57 minus 2n plus 3n minus 1 equals to 5760. So simplifying this would be 3n times 57 minus 1, that's 56, plus 3n minus 2n, that's n. And that is equals to 5760. Now let's expand everything out. So 56 times 3n, that's 168n, and 3n times n, that's 3n squared, equals to 5760. So let's move everything to the left-hand side. We'll get 3n squared plus 168n minus 5760 equals to 0. Okay, let's see if we can simplify the coefficients. Yes, we can. So we'll divide the coefficients by 3. We'll get n squared plus, so say divide by 3, 56n minus 5760 divided by 3 minus 1920 equals to 0. Okay, so we're given a quadratic equation to solve. So you can either use your quadratic formula of factorization. So here I'm going to try to factorize. So I got n minus 24 times n plus 80 equals to 0. So let's equate both factors to 0. So n minus 24 equals to 0, you'll get n equals to 24. And n plus 80 equals to 0, you will get n equals to minus 80. So we clearly know that n cannot be negative. So hence we're going to reject this. So this is our value of n, 24. And using this, we can find the value of a, which would just be 57 minus 2 times n, which is 24. Putting it into a calculator, you'll get 57 minus 2 times 24, which will give you 9. So this is our final answer. These are final answers for these questions. Let's head on to the next question. Okay, so for this question, we're told that a curve is such that dy dx is equal to this expression. And for the first question, we're going to have to find the set of values of x for which y decreases as x increases. So what do they mean by when they say y decreases as x decreases? So let's try to sketch the function. Let's see it visually. So y decreases as x increases. So the function would be like this. It would like be decreasing function. It would be a decreasing function. So basically, they're telling us to find the values of x as or y, the values of x for which y is a decreasing function. So hence, we're going to have to equate dy dx to less than 0, since the gradient of a decreasing function is always negative. So dy dx less than 0 will get this quadratic inequality, 3x squared plus 10x minus 8 equals to negative, is less than 0. So to solve a quadratic inequality, let's try to first factorize it. So 3x squared 10x minus 8. So you would get 3x minus 2 times x plus 4 less than 0. And now let's try to find the critical points of this function when we equate it to 0. So let's sketch the function. So it would be a positive quadratic curve with a minimum point, since the coefficient of x is positive. So let's draw the x-axis right here. So these would be our critical points. So we have 3x minus 2 equals to 0. We will get 2/3. Sorry, pen's not working. Okay, 2/3. and then x plus 4 equals to 0, we'll get x equals to negative 4. So these are our critical points in here. So since we're interested in x being less than 0, we're going to look at the region below the x-axis. So basically, this is the region that we're interested in, and hence our set of values of x are between -4 and 2/3. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're told that it's given that the maximum point of the curve has y coordinate 27. And using this, we're supposed to find the equation of the curve. Okay, so as we know, the maximum point is a stationary point, and hence at the maximum point dy dx would always be equal to 0. So first, let's take the expression of dy dx. So 3x squared plus 10x minus 8 and equate it to 0. And we should already know the answer because we have already solved it. So I'm not going to explain it much here. So you would get 3x minus 2 equals to 0, and x would be 2 over 3. And then this would be x plus 4 equals to 0. X would be minus 4. Okay. So now we are, okay. Let's figure out which value to reject. Okay, so for the maximum point, the second derivative, d square y dx squared, it must be less than 0. So it has to be negative. So let's find d square y dx squared, and you do that by differentiating with respect to x dy dx. So let's find out d dx times 3x squared plus 10x minus 8. You would get, okay, so differentiating 3x squared, keep the 3 at the front, and differentiate x squared, you'll get 2x. So this is 6x. And differentiating 10x, keep the 10 at the front, and differentiate x, you'll get 1, so plus 10. And then minus 8, differentiated, you'll get 0. So d square y dx squared is 6x plus 10. And which value of x, when substituted into d square y dx squared, will give us a negative value? As you can see, it is clearly x equals to negative 4. So we're going to sub x equals to negative 4 into the square y dx squared. We'll get x minus 4 plus 10, which will be minus 24 plus 10, which is negative 14. So hence, x is equals to negative 4 and y is equals to 27. Okay, now let's find the equation of the curve. So to do that, we're going to have to find x in terms of, we're going to have to find y in terms of x. And to do that, we're going to have to integrate dy dx with respect to x. So integrating that, we will get 3x squared. We have to integrate this expression. So integrating that, let's first integrate 3x squared. So ignore the constant term, and we integrate x squared. So that will be x to the power of 3 divided by 3. And then now we integrate. 10x, so keep the 10 and integrate the x. So that would be x squared over 2 and then minus 8x plus c. So simplifying, we'll get x cubed plus 5x squared minus 8x plus c. Okay, now let's substitute x minus 4 and y equals to 27. So this would be minus 4 cubed plus minus 5 plus 5 minus 4 squared minus 8 times minus 4 plus 3 equals to 27. And this would give you c equals to, just type it into your calculator. That's 48. So 27 minus 48, that will give you c equals to negative 21. And hence, our final answer would be y equals to x cubed plus 5x squared minus 8x minus 21. So this is our final answer for this part and this whole question. Let's head on to the next question. Okay, so for this question, we're given a diagram that shows a square ABCD where each side has length 12 cm. So all these sides have the same length, and points E and F lie on the sides B, C, and CD respectively. So we can clearly see it in here and are such that BE is equals to 1/3 BC and DF is equals to 1/3 DC. The arc EF is part of a circle with a center A. Okay, so this is the radius of the circle, AE and AF, and the shaded region is bounded by the arc AF and the line segments EC and FC. And for the first part, we're going to have to show that the size of the angle EAF, so this angle, we'll call it theta, is equals to 0.92373 radians, correct to 4SF. Okay, so in order to do this, we're going to have to know these two angles, like the size of these two angles first. So I'll let this be alpha, and yeah, this will also be alpha since, okay, so there are two right angle triangles, right angle triangle ABE and triangle ADF. So let's use our basic trigonometry ratios. So R is the hypotenuse and side AB is the adjacent side with respect to angle alpha. So we can write cosine alpha is equal to 12 over R. Okay, we don't know R, so we cannot use this. Okay, let's use this piece of information. BE is 1/3 of BC. So we know that BC is 12, so 1/3 of BC would just be 4 cm. And then DF is 1/3 of DC. DC is 12 cm, so DF would also be 4 cm. So now we can write sine alpha as opposite, which is 4 over the hypotenuse, which is 12. Oh, wait, sorry, no, not the hypotenuse. Sorry. Supposed to be tangent alpha, opposite over hypotenuse. So tangent alpha is equals to 4 over 12. And alpha is tangent inverse 1/3. Okay, So to find EAF, you just take 90, oh wait, sorry, not 90 degrees, pi over 2 minus 2 alpha. So pi over 2 minus 2 tangent inverse 1/3. So just type it into your calculator. Make sure your calculator is in radian mode. So this would give you 0.9273 radians to 4 SF. So this is our final answer for part A. Let's head on to the next part. Okay, so for this part, we're just gonna have to find the perimeter of the shaded region. Okay, so to do that, we're gonna have to find the length of the arc EF as well as the length of FC and EC. So for FC, it'll be equal to EC. It'll just be 2/3 of the total length of the side, which is 12. So that is just 8 cm. And to find the length of the arc EF, we can make use of the arc length of a circle formula in here, which is just r theta, where theta is in radians. So arc EF is just r theta. And to find r, we can use the Pythagoras theorem, okay? Because r is the hypotenuse, so r would just be 12 square plus 4 square square rooted, and then theta is 0.9273. Okay, and hence the perimeter would just be the sum of all these sides. Okay, so 12 squared plus 4 squared, 160. 160 square root is 4 square root 10, 0.9273 plus 8 plus 8. And substituting this into the perimeter, we'll get 27.7 centimeters to 3 SF. So this is our final answer. For this part, let's head on to the final and next part. Okay, so for this part, we're just going to find the area of the shaded region. Okay, so to do that, we're going to have to find the area of the square, followed by the area of these two right angle triangles, triangles ABE and ADF, and this sector of the circle. Okay, so first of all, area of square is just 12 times 12, which is 144 centimeters squared. And area of triangle ABE is equal to the area of ADF, which is half times the base, 12 times the height, 4. And that's equals to 24 centimeters square. And then the area of the sector, the formula for this is half r squared theta, where theta is in radians. So half r squared is just 4 square root 10 squared, and theta is 0.9273. So simplifying half times 4 square root 10 squared, you would get 80 times 0.9273. Okay, so hence the shaded region would just be the area of the square, 144, minus the area of the two triangles, which is 24 minus 24, and the area of the sector, which is 80 times 0.9273. So putting it all, just typing it into your calculator, you would get 21.8 centimeters squared to 3SF. So this would be our final answer for this part. Let's head on to the next question. Okay, so we're told that 3 points PQR have coordinates -13.5, 5.1, and 2K, where K is a constant. It is given that angle PRQ is a right angle. And then for the first part, we have to show that one of the possible values of K is 10 and find the other possible value. Okay, so, excuse me. Okay, so in order to do this question, let's sketch like the points, okay? So point P is somewhere here, and then point Q is here. And okay, and then point Q and point R, sorry, is somewhere here. Or it could be up here as well. Okay, whatever. Like the position could vary for point R. Okay, so let's assume that's the position and let's sketch sorry, it's not too good. Okay, let's try to sketch PQR, the angle PQR. So this is a right angle. Okay. So this is our sketch of what's going on, basically. Yeah, so for coordinate geometry, always try to sketch out whatever information you're given. Then it would be much easier for you to solve. Okay? All right, so since we know that angle P, wait, angle, oh, this is supposed to be R, sorry. So yeah, angle PRQ is the right angle. We can conclude that PR and lines PR and QR, they're meeting at right angles. And for lines meeting at right angles, the product of their gradients will always be equal to -1. So we're going to use this result to find K. Okay, so let's find the gradient of line PR. So that would just be the y-coordinate of R, which is K, minus the y-coordinate of P, which is 5, over the x-coordinate of R, minus the x-coordinate of P, which is -13. So 2 plus 13. So this would give you K minus 5 over 15. Okay, and now let's find the gradient of the line QR. So to do that, we're gonna have to subtract the y-coordinate of R, which is K, minus the y-coordinate of Q, which is 1, over the x-coordinate of R, which is 2, and minus the x-coordinate of Q, which is 5. Okay, all right. So this would be k minus 1 over minus 5 plus 2, that's minus 3. Okay, so let's multiply these together and equate them to -1. Okay, so let's multiply and combine it into a single equation. So minus 3 times 15, that's minus 45, equals to minus 1. This would be, okay, let's expand the quadratic expansion, the quadratic expression. So k times k, that's k squared, minus 1 times k, that's minus k, and k times minus 5, that's minus 5k. So this is minus 6k. And minus 1 times minus 5, that's plus 5, equals to minus 1 times minus 45, which is just 45. Let's move everything towards the left-hand side. So we'll get k squared minus 6k plus 5 minus 45, which is minus 40, equals to 0. So here we have a quadratic equation to solve. So you can either do it by factorization or using the quadratic formula. So here I'm going to choose the factorization method. You can also use the quadratic formula if that's what you prefer. So this would be k minus 10 times k plus 4. So equate each factor to 0. So k minus 1 equals to 0. We get k equals to 10. And that's the required answer that we're required to show at the start. So shown. And the other value would just be k plus 4 equals to 0, also known as k equals to minus 4. So these are our two final answers for this part. Let's head on to the next part. Okay, so for this part, we're now told that k equals to 10 and a circle passes through the points P, Q, and R. And here we're going to have to find the equation of the tangent to the circle at R. And we're supposed to give our answer in the form ax plus by plus c equals to 0, where a, b, and c are integers. Okay, so first of all, let's sketch the points. So as we know, PRQ is a right angle. Okay, so let's sketch. Okay, so point P is -13.5. So somewhere here, P, and then point R. Point R is 2. So point R is all the way up there. And point Q is 5, 1, which is somewhere here. So this is PRQ. So, sorry, okay, let me make this sketch a bit more accurate. Okay, and yeah, so this is a right angle, and we're told that the circle passes through all these 3 points. So just drawing a part of this circle, okay? So using our circle theorems, we can conclude that this line PQ is 180 degrees and hence is a straight line. And hence we can say that PQ is the diameter of the circle. And using this, we can find the center of the circle, C. So let's do that. So center C would just be the sum of the x coordinates of P and Q divided by 2. So P's x coordinate is -13 and Q's is 5. So -13 plus 5 divided by 2, comma, 5 plus 1. So that's the y coordinates divided by 2. So for the center, we would get -8 divided by 2, which is -4, comma 6 divided by 2, which is 3. Okay, and now we are going to find the gradient of the line from the center to point R. So the gradient of RC would just be the y coordinate of C minus the y coordinate of R, which is 10, over the y coordinate of C, over the x coordinate of C minus the x coordinate of R, which is 2. So putting all this together, you get 7 over 6. So this is the gradient of the line RC. Now we can find the gradient of the tangent. So since the tangent is perpendicular to this line RC, we can say that the product of the gradients is -1. So to find this, just divide -1 by the gradient of RC. You would get -6 over 7. And hence, we can write the equation of tangent as y equals to -6 over 7 x plus c. And to find the remaining equation, just substitute the coordinates of R, which is x equals to 2 and y equals to 10. So you would get 6 over 7, 2, plus c equals to 10. And then c would be 10 plus 12 over 7, which is equals to 82 over 7. Hence, y is equal to -6 over 7x plus 82 over 7. Now let's multiply both sides by the equation by 7 to get it into this form. Since a, b, and c have to be integers, so this would be 7y equals to -6x plus 82. And finally, let's move everything to the left-hand side. We'll get, adding 6x, we'll get 6x plus 7y, and subtracting 82 from both sides, we'll get -82 equals to 0. So this is our final answer for this question. Let's head on to the next part, next question. Okay, so for this question, we're told that a curve C has this equation. And for part A, we're going to have to find the coordinates of the two stationary points. Okay, so to find the stationary points, we have to know that at the stationary points, dy dx would be equal to 0. Okay, so first of all, let's express y as 9 times 2x minus 5 to the power of -1 plus 2x minus 5. Okay, and now let's find dy dx. So dy dx would just differentiate the whole right-hand side. So to do that, we'll first differentiate 9 times 2x minus 5 to the power of negative 1. So keep 9 and we differentiate 2x minus 5 to the power of negative 1. So to do that, bring negative 1 to the front times 2x minus 5 minus 1, subtract 1 from the existing part, so this would be minus 2, and differentiate the inner function 2x minus 5, so this would be 2. And now differentiate 2x, you'll get 2. Differentiate 5, you'll get 0. Okay, and then so this would just be 9 times negative 2, which is negative 18 over 2x minus 5 squared, because we have 2x minus 5 to the power of negative 2, negative to the power of negative 2, and that's the same thing as 1 over 2x minus 5 to the power of negative 2 plus 2. Okay, now let's substitute dy dx equals to 0. So this would be minus 18 over 2x minus 5 squared plus 2 equals to 0. Move the minus 18 over 2x minus 5 squared to the other side, you'll get 18 over 2x minus 5 squared equals to 2. And hence, you can equate 2x minus 5 squared with 18 divided by 2, which is 9. Okay, and now we can square root both sides. We'll get 2x minus 5 equals to plus or minus 3. So 2x is either equal to 8, and then you'll get x equals to 4, or 2x would be 2, and then you'll get x, 2, minus 3 plus 5, that's 2. Then you'll get x equals to 1. So this is the first set of x coordinates. Now let's just find the y coordinates. So y equals to 9 over 2x minus 5. So for this, we took the positive value, 3, plus 3. So 9 divided by 3 is 3. 3 plus 3 is 6. And then for this, it would just be 9 over minus 3. Sorry, minus 3. So this would be minus 3, which is minus 6. Okay, so hence our final answer would be 4, 6, and 1, negative 6. So these are our final answers for this question. Let's head on to the next part. Okay, so now for this part, we're going to have to find d squared y dx squared, and hence determine the nature of each stationary point. Okay, so first of all, let's find d squared y dx squared. And to find that, you just differentiate your dy dx. So our dy dx we found in the previous part, that's minus 18 times 2x minus 5 to the power of negative 2 plus 2. So to differentiate this, you first differentiate the first term, minus 18 times 2x minus 5 to the power of negative 2. Okay, so you take out the scalar, which is minus 18, and you differentiate 2x minus 5 to the power of negative 2. So to do that, bring the original power to the front, and subtract 1 from the original power, you'll get minus 3. And then multiply by the derivative of the inner function, 2x minus 5, so that would be 2. And plus the derivative of 2, which is 0, because the derivative of any constant is 0. And hence, this would just be 36 times 2, which is 72 over 2x minus 5 cubed. Okay. Yep. Yeah. So this is d squared y dx squared. Now we're going to determine the nature. So to do that, just substitute the corresponding x coordinates. So first we'll find the nature for 4, 6. So we'll sub x equals to 4. Okay, so 72 over 2x is 2 times 4, that's 8, minus 5 cubed equals to 72 over 8 minus 5 cubed. That's 8 over 3. So since d squared y dx squared is more than 0, or 6 is a minimum point. Okay, and now we're going to substitute x equals to 1 to determine the nature of 1, negative 6. So this would be 72 over 2 minus 5 cubed, which is equal to 72 over 2 minus 5 cubed, which is minus 8 over 3. And so for here, dxy dx squared is less than 0. So we can conclude 1, negative 6 is a maximum point. So these are our final answers for this question. Let's head on to the next part. Okay, so for this part, we're told that the curve C is transformed to the curve C1 using a translation of minus 3, 7, followed by reflection in the x-axis. And for the first part, we're supposed to state the coordinates of the maximum point of C1. Okay, so first of all, we have to take note that the maximum point of C1 before it was transformed, it was the minimum point of C because it was reflected over the x-axis. So its y-coordinate was multiplied by -1, and hence it changed from its nature was changed. Okay, so let's take the coordinates of the minimum point for 6 and apply the transformations. So the first transformations, minus 3, 7, you just subtract 3 from the x coordinate because it is moved 3 units to the left. So this would be 1. And then you add 7 to the y coordinate because it's moved 7 units up vertically. So this would be 113. And then finally, it's reflected in the x-axis, so you should multiply the y-coordinate by -1. So this is 1, negative 13. So hence our answer is 1, negative 13. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're going to have to find the equation of C1 in the form y equals this, where a, b, c, d, and e are integers. Okay, first of all, let's write the equation of C. which is 9 over 2x minus 5 plus 2x minus 5. And to apply the first transformation, or the translation of negative 3, 7, you're going to have to replace x with x plus 3, because x is negative 3. And so when you make the right-hand side equals to 0, you get x plus 3. Okay, so this is that. And then, yeah, just replace the x with x plus 3 minus 5 and add 7 to the whole equation, because you're shifting up the y coordinate by 7 units. So simplifying this, you will get 9 over 2x plus 6 minus 5, that's 1, plus 2x plus 2 times 3, that's 6 minus 5, that's 1 plus 7, that's 8. Okay. Yep. All right. And then to apply the final transformation, the reflection in the x-axis, just multiply the whole equation of the curve by -1. So you'll get y equals to negative 9 over 2x plus 1, negative 2x minus 8. So this is our final answer for this part. Let's head on to the next question. Okay, so in this question, we're told the function f is defined by fx equals to x squared plus 4ax plus a for x all real numbers, where a is a constant, and the function g is such that g inverse x is this for all real numbers of x. Okay, and then for part A, we're told that given that the range of f is fx equals to or more than -33, we're supposed to find the possible values of a. Okay, so first of all, let's complete the square for fx. So to do that, make sure the coefficient of x squared is 1. So in this case it is. So you can write x plus, divide the coefficient of x by 2. So you'll get 2a squared minus 2a squared plus a. And then you would get x plus 2a squared plus a minus 4a squared. Okay. All right. And then using this, you can find the minimum point of this in terms of a, because this -33 is actually the minimum point or the turning point, the y coordinate. So can sub x plus 2a equals to 0. So you'll get a minus 4a squared, it's equal to -33. So this would just be 4a squared minus a minus 33 equals to 0. And now we've got a quadratic in terms of a. We can now solve this equation either by factorizing or the quadratic formula. So here I'm going to try to factorize. So I got a minus 3 and 4a plus 11 equals to 0. Now I'm going to equate each factor to 0. So a minus 3 equals to 0, we get a equals to 3. And 4a plus 11 equals to 0, we get a equals to -11 over. So this is our final answer for this part Let's head on to the next part. Okay, so now we're told that instead fgg0 is equals to 96. We're going to have to find the value of a. Okay, so this is a composite function that is in terms of fx and gx. So to do this, let's take the inverse of g. Okay, so g inverse x is equal to this cube root of 2x minus 4. Okay, so to find gx, we're going to let g inverse x be y to x minus 4. Now we're going to swap the x's and the y's. So now x equals to 2y minus 4 cube rooted, and we're going to make y the subject. So to do that, we're first going to get rid of the cube root. So this would be x cubed equals to 2y minus 4. And then we'll make y the subject. So this is 2y equals to x cubed plus 4. And then y would be x cubed plus 4 divided by 2. So this is y cubed divided by 2 plus 2. So hence, gx is equals to x cubed plus 2 plus 2. Okay, now let's find f g g0. So to do this, we're going to have to first find g0. That's just 0 cubed plus 2 plus 2, which is 2. And g0, that's again equal to g0, which is equals to 2. And fg0, that's just equal to f2, which we can just use our formula for f, which is x squared. X squared is 2 squared plus 4ax. 4 times 2ax plus a. Yeah, this is equal to a plus 4 plus 8a, which is equals to 9a plus 4. So this we can equate it to 96. And then we get 9a is equals to 92. Wait a minute. Let's see if I'm correct. Okay, let's see. Oh, sorry. Sorry. I made a mistake. So this G0, this is supposed to be G2, which is just 2 cubed, 2 cubed over 2 plus 2. That's 8 divided by 2, which is 4. 4 plus 2, that is 6. And hence FGG0, that's just the same as F6, which is equals to x squared. So 6 squared plus 4ax, 4a6 plus a. So simplifying, we'll get 24a plus a, that's 25a, and 6 squared, that's 36. And this, we're going to equate it to 96. So 25a is equal to 60, and a would be equal to 60 divided by 25, 12 over 5. So this is our final answer. Let's check everything for one last time. Okay. All right. Yep, nothing wrong. G0, yeah, G0 is 2. G0, yeah, that's G2, which is 8. Yep, okay, that's F6. Yep, this is indeed our final answer, and we have come to the end of this paper. So I hope you found this video helpful, and if you did, please like and share this video and subscribe to this channel for more future past paper solutions for A-level maths and further maths. If you have any questions or doubts, feel free to leave them down in the comments below, or please let me please let me know what other past papers you would like to see me solve next. And I'll see you again next time. Okay, thank you.